Am I audible? You can hear me, right? All right. Hello, everyone. So, welcome to our week 3 workshop series. Uh, Before I begin, I would like to know like how many of you are new? No, so all of you attended like the previous workshop, right? Okay. So let me introduce myself. My name is Krishna Singh Rajput. I'm currently pursuing masters in data science here at ISU. Um, and I am serving as a machine learning domain head here at the AI Society. And we are conducting this weekly workshop. And the goal is to cover all the basic machine learning concepts. And at the end of towards the end of the series, we will have an recommender system like hands-on project. So far we covered the data pre-processing and data cleaning and feature engineering and couple of other things. And all those steps and methodologies are applicable for all the ML projects. And today's workshop is going to be more on the feature generation for the text data, which covers which comes basically under the NLP section. But from because it was the requirement for the project, since we are building a recommender system and mostly we have the text data, so we need to learn this step as well. From next workshop onward, we will cover the machine learning algorithms. We will start with classification, supervised learning, and then we will go in unsupervised learning, like clustering and other methods as well. And towards the end, we will build a event recommender system. All right, so let me begin. In today's workshop, we will understand how to handle text data, how to extract features from the data, and how to create TF IDF, which we will understand later on. So before we begin, all of you are aware that we use Google Colab for the hands-on. Basically, it's a cloud-based platform where we don't really need to install lots of libraries and other dependencies. But sometimes we do need certain specific libraries for our task. And today we will need to install a couple of libraries. And the way we can do it is we use this symbol, this exclamation symbol. I'm sorry. So here if you see, in the Jupyter Notebook cell, we use this exclamation mark, which basically tells that we are running bash command. And there we use pip, which is a package manager. So what package manager does, it basically helps us download and manage all the different modules, libraries, and their dependencies. Uh, so let's begin. I think all of you have already access to the code file and the data file. Even if you don't have like the data file, the link is also available in the notebook file, which will look something like that. So I'll allow you a couple of minutes to set up if you want to work with me.
Where can we get this link?
It's available in the Discord channel.
I would suggest you join there because all the relevant PPT material, everything will be put up on Discord.
If you want the link to Discord, I think it's in the towards the end of the. So here is the link. Just try to type this link on your browser if you don't have access to the Discord channel. All of you can read the link, right? So let me repeat the link. It's https slash www.bit.ly slash capital A, capital I, capital S, dash, capital L, INKS. Thanks.
Click the right link and inside that you will have a folder called week 3. And inside that you can find the Python and the data.
I can just see week 1 and 2. Okay, got it. And now
Is there anyone left still who haven't got the access to the code file? All right. What's the issue you're facing?
Just refresh it once. And send an updated link, right? Yeah, make sure you are in the ML lab. So there are 2 labs, and if you go to the machine learning channel, there you can find the ML lab and NLP lab. So make sure you open the ML lab one. I'm sending it again.
Pooja, the link to the week 3 is available in the ML domain channel. We can like share it to the.
No, it's there. It's already on.
Okay. You have the access to the Discord channel, right? Then just go to. Okay, she'll help you.
Send a new link if just for verification. Just open that and link week.
open this Google Collabs file. So it is asking you to download it.
Yeah, so just download this file and open it in Google Colab. So the way you do it is just go to the Google. You can see my screen, right? Just write Google Colab. Sign in with your Google ID. And here you can see this option upload. And from there, you can upload this file, the Google Colab file. And also, the moment you upload this file, just I'll walk you through the steps. So the file will look something like that. And you need to upload the data file as well. The way you do it is just click this icon, this folder icon over here. And here you will see this icon. Can you see, all of you, right in the corner? So just click on the upload, and here upload the data set, the CSV file, which is also available in the same folder. And right after you upload it, you will see it right here. The way like here you see this data set, it will show something like that, .csv file. And the way we import it is just we'll import the basic libraries which are available in the code. Just run these cells. Right after that, when you see this pandas command, this everything which is written in this red color, this everything, replace this with the path. And the way you capture the path is just go to this menu, click on these 3 dots, and there is this option copy path. So there, just copy the path for the data set which you have uploaded, and then put that over here in the read CSV function. And for those of you who are new, who don't know how to run these cells, there are multiple ways you can do it. So if you see there is this icon, you can click on this and it will run the cell, or you can just hit Shift plus Enter and it will do the same thing. Anyone who is still in the process to set up the code? Okay, so let's just get started. So just like we covered in the last workshop, we will start with loading the data. And for that, we use the pandas library. It is one of the most popular and advanced library, which is used for data manipulation. And the data set here we are working with, this is the event data set, which we have worked on data cleaning and all those steps so far in last two workshop. So this is the same data set which we generated in the last workshop. Just take a look. You will see there are multiple entries of the events. You have the event name, date time, the description, hosting organization, event perks, location, and event weekend feature. So this event weekend feature is something we generated in the very end of the last workshop for data visualization purpose, but still I have kept it for this task. You will understand why in later on. So we can use this function like .shape to get the dimension of the data set, and this data.columns to get all the list of columns or features we say in this context. So these are all the basic things we covered in the last two workshop as well. So far, any doubt? Okay, all right. So let me remind you again that today's topic is going to be a little bit advanced, and this we are basically covering the feature generation for text data. So all the steps we are going to learn today, these are only valid for textual data. So let's start with the feature transformation. All right. So what is feature transformation? Basically, feature transformation is a process of converting the text data into numerical format. One might ask, why are we converting the text data into a numerical format? So any one of you would like to answer this question? Any volunteer? So basically, if you have a look at the data right here, so this is how our data set looks like. So there you see this rows and columns. This is like a tabular format, the one we see in Excel as well. So we have all the details of the event, but the machine does not understand the information. It does not know what white elephant means basically. And machine can only handle the numerical data, because some of you might already know that all of our machines works on 0 and 1 in the binary system. So the way we make the text data understand to the machine, for that we perform multiple steps, and for that we need feature transformation. So let's say I got this data and I want to use this description. So I have this description. Let me print it out for you. Let's say I want to know data. So basically, I have printed a couple of entries from the description column. So if you see, it's written as in the first one, are you interested in learning how to code? But this information, we humans understand the language because this is why we call it natural language. But the machine have no idea what this sentence mean. And the way we can do it is, so we can break these individual words and we can tell that whenever you see the individual word, just the machine does not need to know the context, but it can understand that if there is something written as are you interested in learning how to code, so the word code and interested and learning, these three words have more relevance compared to other words, because by just looking at these three words, we humans can make sense that it's talking about uh, coding basically, because there is this word code used here, and learning. So it's basically related to educational kind of thing, maybe an event or maybe a workshop like this one. For this, the way we make the machine understand all these steps combine, basically called as feature transformation. So first we transform this information into features, and then we perform different kind of techniques we will learn in this workshop. So let's begin the feature transformation. Even if you don't understand it right now, it's fine. We will have a look in detail at each step. So for the text data, we need to use a couple of more libraries we haven't used so far. So one is this which is basically handle the regex. If you don't know what regex is, it's fine. We don't need to know that. Uh, we need this contractions. This is just a library. You will understand the significance and the why we are using this. But this contraction library is not or pre-installed in the Google Colab. And the way we can install is we can write this command, just like I already showed you in the first slide. We'll start with the command pip install contractions, and it will get the job done. So coming back to feature transformation, basically in this step, I have mentioned it a couple of times by now, we convert the text data into different features, and those features are a numerical format which the machine can understand. For that, there are multiple steps involved. The first one is again cleaning. Don't confuse this with the data cleaning. The data cleaning we did earlier, that is applicable to all of the machine learning project. But here we are only focusing on the text data. And this step basically depends on the type of analysis we are trying to perform and the type of data we have. So let's first understand that what are the important information available in the text data we have, and whatever the information which is not important or not related in that context, we can remove it. So the first thing we do is we remove the HTML tags. So what are HTML tags? Basically, whenever we web scrape any data, HTML is basically you can say it's a language in which all the applications you see for the front end, it's all built in with the HTML and CSS. So sometimes you get HTML tags which are annoying and they don't have any significance. The only reason we have those HTML tags is because our web scraping process was not 100% efficient. So we need to remove those tags because they don't have any information which is useful in our analysis. The way we do it is, so if you see over here, let me zoom in. So focus on these line only. So that is why we use Python, because Python is really easy. We can perform any task with a few lines of code. So here, if you see, we removed all the HTML tags with just a single line of code. And the code is the data. Data is the framework, basically the data frame. And we are using the re library. And there is this function built into the re library, which is sub. And here we are, so this one in the re is basically regex. And if you see this R followed by something, it tells that there is a pattern. So there is a pattern which goes something like this. So what this line is saying that remove, like replace. This sub function is used to replace. What are we trying to replace? We are trying to replace whatever is in between these two. So you see this greater than and less than symbol, and whatever is in between the two, including those two, we will replace it with nothing. So this is the function we write to remove all the HTML tags. And we can perform all these steps in any of our feature. Let me start doing that over here. I'll go a little bit slow because today we will cover some advanced topics, but we won't cover too much. So we have enough time. Feel free to ask if you get stuck at any step or you feel there is something you are not understanding. Here you see the feature transformation. Here I have defined this function. And in Python, the way we define any function is we write def followed by the name of the function, and then we write whatever we want to do in that function. So basically, this function is a pipeline, and pipeline is nothing but a series of operation I want to do. So instead of going into that, just focus on individual column for now. So let's remove HTML. So the way we remove HTML is basically we are saying that this data dot any column. So we can use the description. So these are the column I have, and most of the information which is useful for our analysis is in the description column. We will use the information from other columns as well, and you will understand why I defined a single function and put every step in that. So for our understanding for now, we can say that data.description is equal to this function applied over see what's the error. All right, we can say that data dot description dot apply. So that's how we apply any function. And here you see this function is basically to convert that particular column on which we are calling this function into a lowercase. But we will get to that. Here, whatever the function we write, this is going to be the same command which we wrote in that function. So what this line of code will do is it will convert, it will remove all the HTML tags from the description column from our data set. But here, since we want to perform all the same pre-processing steps into all of our features, which are important, we are basically defining this function so that later on we can perform all these tasks with a single line of code. So we are starting with this HTML. So using this re library, we are going to remove the HTML tabs. The second step we will perform is removing the special character. So there are always special characters like asterisks or maybe some symbol which does not have any important information for analysis. And the way we do that is, again, we are using the re library for most of our this pre-processing task, the data cleaning task for the text data. We are going to use this library because this library is used to define patterns, to find patterns in a data. So what we are saying is here, we are removing all the characters. This is the way we do it. You can find more information about the library by typing re library Python. And if you see this, the documentation, you will find all kinds of different patterns and their respective function. All right. So we removed the HTML tags and then we removed the special characters as well. Then we need to convert uh, all the information into lowercase. So let's say there is something written as apple with a capital A and then also apple with a small a. But we are if we are considering each unique word as a different entity, then the machine will recognize these two words as two different things. But we don't want that because these two are the same thing, right? So we need to convert all the text data into lowercase. And the way we do it is just nothing, but we can say that data is equal to data.lower. This is a built-in Python function. All right. So after converting the text data into lowercase, then removing the HTML tag, then we removed special characters. We can further aid to our data cleaning process by removing all the URL which are available because it has no significance. So let's say uh, you have a text saying, check out my website, www.something.com. So we don't need the URL or the link of the website to understand what is going on in that text. So we can understand that by like with this text that check out my website, the thing which is important is that someone is trying to say that here is my website and this is the link, but we don't need the link to get any information. So that is just not so important. Then we can remove the mentions. So what are mentions? Basically, in social media, all of you might have tagged a friend of yours by just writing at the name and everything. So let's say you are talking with your friend on WhatsApp, and there is this group with 10 or 20 people, and you are tagging each other and typing something back and forth. And if you have this data and you want to understand the sentiment. So what is sentiment? Sentiment is basically if a message is positive or negative. And For that, you don't like it's not important the person that tagged in that text. What's important is the rest of the content which is available in that text, regardless of the person they tagged in. And then comes the digits. So digits, this can be controversial. Some of you might agree or some might not agree. So let's say we have text data, and there are digits are basically nothing but numerical values. So we have something that let's say it says the event is going to start at 2. So the number 2 has significance uh, because without the number 2, we don't know when the event is going to start. But if we are trying to just like in our case, we are trying to build a recommender system. For that, we don't need if the event is going to start at 5 or 6 or something like that, because we already have a date time column. There, the date and the time of the event is already available. So we don't need that information. So we can basically remove it. So removing of digits and like all the things we are doing so far, this is very subjective and it depends on the task you are performing. So let's say you are working in a finance sector. Their numbers might be more important than any other information from the text. So it depends on the context, whether you want to remove certain thing or not is going to depend on the task you are going to perform and the kind of data you have. So for our case, here we are just trying to build a recommender system. For that, we need to know what the event is all about. So let's say we got to know that an event is about food and music and networking. So a person who is looking for events or a person who is interested in networking, food, and music, we can directly recommend that event to that person without considering the time. We can just show that, hey, there is this event at this time and location. You might be interested in. And later that person can decide if he can make it or not, depending on his or her schedule and availability. So moving on, while we are removing uh, all these different kind of like special character, digit, or URL, HTML, what happens? Sometimes we get extra spaces. So let's say something is written like uh, I don't like food, but the text is written as I space don't double space then like. So this might cause issues with our machine learning task. So it is in the best practice to remove those extra white spaces. And the way we can do it is, again, you can use the regex library, uh, which is available in Python. All right. So now that we have removed most of the unnecessary things from our text data, what are the further steps we can do to make like to improve the quality of the data so that later on, when we generate features out of this data, our machine learning model is can perform better with higher accuracy. So any ideas so far? Just it's fine if you don't understand all these terms or words. Like any basic suggestion, like just imagine that uh, you are teaching all these concepts to your friend who is really dumb. So you got all this data, and that person does not understand English, but that person is really intelligent in a way that that person can remember all these different words, how many times they come in what sequence. So any idea after that? So, okay, moving on. Since we removed most of the unnecessary things from our text data, whatever we are left with is we can say only the important words or the information. But again, if you see this example over there, it's written as can't, but the can't and cannot are basically the same thing. And if you are typing you are in a sort way, it is same as you are, but the machine will consider these two cases as different one. It won't be able to understand that these are the same thing. So what we can do is we can make a list of all of such word. So for example, we have this can't, you are, or don't, maybe other. So the way we can do it is there are multiple ways. First, we can make a list. We can think about it and generate a list and then replace all those words. So let's say we generated this list of only two words, this can't and your. Then we can use Python and replace all the can't with cannot. But this is something which is not feasible, right? Because you might come up with 50 such word, or maybe let's say 20. But what about the other words? So what people did is they collectively created, so many people gathered and they contributed toward a corpus, and which is available in the NLTK library. And there are other libraries to perform the same task as well. And they made this list for us. So we don't need to make this list ourselves. Instead, we can directly use the NLTK package. The way we do it is, so sorry about that. So we are not going to use the NLTK library. We are going to use contractions library, which we imported earlier. Here you see, we installed this library and imported the library. So this library is basically responsible to handle this kind of thing. And here we can perform contractions with just a single line of code. We can just use the library's fixed built-in function and just pass it through the data. All right, moving on. So even after removing all the unnecessary information and converting the word in a way that the similar word have similar meaning for the machine as well, there are still lots of things we can do. And this is a basically endless process. It depends on the level of accuracy you want to achieve and the amount of time you want to put in. That will determine the number of steps you are going to follow for this data cleaning process. So the last step we are going to use for our event recommendation project is removing the stop word. So what are stop words basically? If I want to say something, I'll use, let's say that I like coding and my friend is really bad at coding. So in this sentence, if you see that my friend is, so this word is and all these article and there are such kind of word which does not add any value in the information. They will still be the same. So just to give you an example, if you are analyzing a review like the food of this restaurant is amazing, the word the at is don't tell us much. It will still be the same if we read it like this. Food, this restaurant, amazing. Still, we can make sense that this person is talking positively about the food of a certain restaurant. So removing such kind of word, this step is known as stop word removal. And for this, we use this NLTK library, which we imported earlier. So here is the code. You see, so we use this NLTK. There is this corpus. Corpus is again basically a list, you can say, of all the stop word, and we are using those stop word in the language English. So we need to define that for the English language, we need all the stop word, and this library will basically use all the list of the stop word for English language and remove it from our data. And if you want to just visualize what will happen after that, so there is this sentence. The quick brown fox jump wasn't high enough. It didn't clear the 3.5-foot fence. So after performing this step, it will look something like quick brown fox jump wasn't high enough, didn't clear. It says now 35, but we are anyway going to we are going to remove all the digits. So converting 3.5 into 35, it's not going to be issue for us. Food fence. So if you read these two sentences, you can see that much of the information is preserved. You can still make sense of the sentence by just looking at the letter output, which is generated after removing all the stop words. So that's why we perform the stop word removal. And after that, we will hopefully we get a lot more cleaner data we can use to build our machine learning model. So any doubt so far? Yes.
So, like in the first line, you then please subscribe to the code.
The code? Yeah.
So in that, while we are trying to change our data to lower case, so what is
Right.
like
Okay.
if statement? What is that? Can you please-
Oh, yeah. So basically, I defined this function which says process text so that I can perform all these series of operations on all the features combined, so that it will be quicker for me, because I don't want to implement all these steps for each of the features separately. And for that, what really happens is sometimes we have the data in the pandas series data type, and or sometimes we don't, like we might have array of text. So that's why I use this if else statement. So let's say you have this data in a pandas series format, then you can use the pandas built-in function to convert it into lowercase. Or if you don't have a pandas data frame, then it will go into the else statement and it will use the Python's built-in function, which is dot lower, and it will convert the text into lowercase. You got it right?
Yeah.
All right. So any doubt so far? So this is like a really crucial step. We covered lots of things, and I assume that all of these steps are new to you. So if you have any doubt, just feel free to ask. And just to get a gist, so far what we did, we got the data set from ASU website, we scraped it, and in the initial two workshop, we performed the data cleaning, the feature generation, data visualization, and here we are trying to convert this text data into features we can use for a machine learning model, because our machine learning only understand numerical values. So after that, now I got all the list of the individual word, if you see over here. So our final output looks something like that. I have all these list of words for all the features. Now the way I can make machine learning understand is we are going to use this TF-IDF technique. What this technique is, so this technique basically uses two terms, which is term frequency for TF and inverse document frequency. And it extract, basically it measures the frequency of a word available versus it compare it to the frequency of the word in the document. So basically the inverse frequency, and it makes sure that the word which are more important for our analysis get more values. So for example, wait. All right. So in normal conversation, you might use the word hello very often, but it does not have any useful information most of the time. But words like, let's say, internship or a college test, these information, depending on the context, hold more values. So that's why we use this technique. There are multiple techniques available. And this technique is known as TF-IDF, and it measures how often a term appear in a document. So that is the term frequency. And then it measures inverse document frequency, and it multiplies both of the terms to make sure that the word which are more important gets picked up. And here's the way we can do it manually or mathematically, I would say. So here, if you see, here there are total 5 words. And on the second document, I have 8 words. And there are this word, Jupiter is the largest planet, mass 4th from Sun. So if you see here, this is the term frequency, that all these words appear once in the document. So that's why the frequency is 1 by 5, because there are total 5 words. And for the second document, this word appear 1/8, because this appeared once, and there are total 8 words. So after getting this frequency, similarly, we can get this inverse frequency. And here's the mathematical formula. And after getting the term frequency and inverse document frequency, if we multiply those two, we basically get a number. All right. So the way we do it, we will use the sklearn library. sklearn library is a very famous library, mostly used for the machine learning task. And in that library, we have this feature extraction module, and there you can use the TF-IDF vectorizer. You can import it, and then you can fit and transform into our text data, and it will convert all those words into different features, and it will calculate the TF-IDF frequency, and it will assign a number to that. All right, so if you see after this step, we have the same number of rows which we had for, because we had 376 event, but now we had like 8 columns initially, but after this step, we have 3,604 columns. So these are the features we are going to use in the upcoming machine learning model. So for that model, we are going to use this data set. You can save this data set if you want by just exporting it to CSV. And this command is basically something I have covered in the first workshop as well.
Okay,
So
whatever is left,
no, it's I'm done with that.
Yeah.
So that's it for today, guys. I understand that today was a bit like a different topic, because we were dealing with text data. From next week onward, we will cover machine learning algorithms, and we will use the same data for different tasks. So thank you for today. Yeah. If you feel you have any doubt, like, you can ask on our Discord channel as well, or maybe outside the class. We need to give this room to them.